All right, so this video has been created to help explain the fun little science experiments that I created for all of you great nieces and nephews out there in California. So this video has been created for Jackson and Eliza and little Max, even little Max, and for Mateo and Tiago and little Jojo, and also for Hadley and for Nash. And this video has been also created for Layla and Isla. So I hope you enjoyed the video. I'm going to explain how all the little experiments work. So let's start with the balloon rocket. I hope you had lots of fun with the balloon rocket. And balloon rockets work just like a real rocket would. Balloon rockets work because of some forces that act on the balloon, and it's based on a law of motion developed by this fellow Isaac Newton many years ago. And he was pretty smart, and he developed some what he calls his laws of motion. And this is about the third law of motion, which says that every time there's a push, there's a pull. So in this case, this is how real rockets work. As the air is escaping out the back of the balloon, after you blow it up, the air escapes out, and that gives a little push. What that does is it pulls the rocket the other direction. So for every push, there's a pull. The more you blow up the balloon, the greater force there is of air coming out. And actually, the faster and farther the balloon will go. So if you didn't try that. Try blowing it up just a little bit. Try blowing it up a lot and compare the difference. Okay, next I want to talk about my favorite. My favorite of the experiments was the Gloop. Hopefully, you had a lot of fun making Gloop. And let me explain how it works. It's kind of a little chemistry experiment. So you start out with the glue, the white Elmer's glue, when it's in the liquid state in the bottle. It's these long chains of little molecules. So the glue has all these little particles inside, and they're all moving around. That's why it's liquid. Well, when you add the sodium borate solution to the mix, it causes this chemical reaction where these little branches form between all of the liquidy particles in the glue, and it makes it turn into a solid, and it makes it gloop. So it's kind of cool. It's a little chemistry experiment that happens real quickly there. I want you to try something too. If you have any of the sodium borate solution that's in the colorful bottle, if you have any of that left, I want you to go get the clear gel glue, the kind that has glitter in it. And if you combine that with the sodium borate, you're going to get slime. That's a lot of fun too. So if you want to make some slime, go get the gel glue and mix that with the sodium borate solution, and it's a different kind of a chemical reaction. Okay, hopefully you did the candy chromatography too. That's a lot of fun. Candy chromatography works because the candies, the colorful part of the Skittles, is used with dyes, and dyes are sometimes a blend of different colors. They're not just plain red. Maybe there's some orange in there, or some yellow in there, or sometimes some purple in there. And so chromatography allows you to separate out those colors that are in the dye in the candy, and so you can see all the different colors. So here's how it works. Water, when you put, this is to represent the paper towel or the coffee filter, and when you put that in water, the particles of water travel up. That's when we say it soaks up the water. It's because the particles are traveling. Well, when you have the dye from the candy, the dye travels with it. So as the water's traveling up, the dye is traveling up as well. Well, the dye travels at different rates. Different kinds of dye travel right there with the water, and then other dye, maybe it's heavier, or it just doesn't travel as far. So you see here the green is not traveling as far as the yellow. And so then when it's all finished, the colors get all separated like this. So here we have the red and the yellow. Or here we have some yellow and some blue at the top. And hopefully yours turned out something similar to this. You can use paper towel to do it too. And you can try this same thing with markers, or other kinds of candies, or all kinds of things. You can try separating out the colors and find the hidden colors that were there all along. All right, now let's talk about the helicopter. The helicopter you made, hopefully, you can make a bunch of those, use the same pattern, and you can use different colored paper, and you can use marker on it and decorate them and make bunches of them. But the way that this works is you have air. As you drop it, air pushes up on these two flaps that are at the top. And because they're balanced and you have two of them, it pushes on them equally. It also somewhat diverts the air around, and it ends up pushing here on the sides, and that's what makes it spin. So because it's perfectly balanced, it will spin like that. You could try an experiment and maybe cut one of these flaps a little shorter, or try cutting off part of this side piece and see what happens to your helicopter. Won't that be fun? Did you have fun trying out the comb experiment with bending of water? Well, the way this works is when you comb your hair, you are actually pulling off these teeny little particles out of your hair called electrons. You can't see them. They're so tiny. You can't even see them with a microscope, but they're these teeny little things. And you're pulling those right out of your hair, and they start to build up on the comb. So the comb has all these little particles, and they have a negative charge. Negative charge. It's like a magnet. And then when you place the comb near the water has negative and positive, like a negative and positive magnet. And when you bring the negative comb close to the water, all of the negatives move away. The negatives don't like the negatives. And all the positives, the plus signs, they move toward the comb. The next thing you know, they're attracted to each other like a magnet, and the whole water begins to move toward the comb. So hopefully you saw that, the water moving around when you use the comb. But you can do all kinds of things when you have a charged comb, when you comb your hair with it. Try laying out some black pepper on the table, or some little bits of styrofoam. You can try that and see what happens when you bring the comb near to them. That's a lot of fun. Give that a try. All right, the last one was the Cartesian Diver that you made with the little piece of straw and the clay. The way this thing works is there's a little air bubble inside the straw. If you close it off with the clay, the water doesn't get up in there, and you have a little air bubble. When you squeeze hard on the bottle, it causes an increase of pressure, and it forces some of the water up into the straw. The air bubble gets smaller, and the thing sinks. When you let go, and you're not squeezing it anymore, more air fills up that little piece of straw, and the little straw is lighter, less dense, and it can float up to the top. And so that's like your little diver. You can squeeze it and it sinks, let go, and it floats. This is all based on something called density. If something has low density, it floats up. If it has high density, it sinks. So here's another experiment you can try. You can just decide if things are going to float or sink in water, and you can get yourself a big bowl, or you can fill up the sink with water. And then I want you to try some of these things. First, decide if you think it's going to sink or float. Will a Lego sink or float? How about a penny? How about a paperclip? And then test it out. And then you'll be just like a scientist. I hope you guys have a great Christmas, and I hope you enjoyed your fun little science experiments.